Good morning and happy Friday. We are going to do a little practice today with vectors some more. So I first wanted to go over your homework from 2 days ago, Wednesday. So a lot of you did great with number 2. Here are those answers. I'll just go ahead and tell you that remember there is no subtraction. So we do adding a negative, if I can speak, which you guys, it's really just the same thing as subtraction, okay? And then on this problem here, I wanted to show that I go ahead and distribute the negative and the 3 together. So I just look at it as a negative 3, and then I change it to a positive once I distribute, okay? And then on letter B, when I distribute the negative, notice it becomes a positive, okay? It's just like subtracting polynomials, so that should be fairly familiar to you. All right, on number 3, a lot of you did well with number 3, but I wanted to point out a couple of misconceptions. The biggest one was the direction that we messed up, and then component form, some of us had it backwards. So let's remind each other, for component form, it's like this, and we want it to be the X and then the Y, okay? So if we're starting here and ending here, we want to go left first and then up, okay? So it's left how many? 1, 2, 3. But because we're going to the left, it needs to be negative. And then we're going up 1, 2. Okay? So our component form here should have been negative 3, 2. Some of you had that reversed because you may have gone up and then left. So just make sure we're clear. We want to go X and then Y. Okay? Now, most of you got the magnitude, which is root 13. Just square the 3 is 9, square the 2 is 4. Add them together. Okay, and then the direction, all right, so this we need to be a little clear about. If you were to draw, I guess I actually could leave that. If you were to draw a little X and Y axis right here, I think that would be helpful because here's the thing. It's not in standard position, meaning it's not sitting right here. If it were sitting right there, you could tell it's clearly in quadrant 2. So that's why my suggestion is to always kind of think about drawing an X and Y axis right there at the initial point. And now you can tell it's in quadrant 2. So quadrant 2 means our angle should be, or our direction should be somewhere between 90 degrees and 180 degrees, right? So if you put like 30 or 40 degrees, which some of us did in the 30s and the 40s, you're partly correct, but you're just not all the way correct, okay? So you should do sine of theta prime equals 2 over root 13, okay, because your root 13 is here. And then you get, let me type it in, it's 30 something, I can't remember. 33.7 degrees. Now, that is only this part right here. That's that angle right there, okay? But we want this full angle of where it's located. So the point of finding the 33 is to help us find what the full angle is. So to find theta, oops, let me change my width. To find the actual theta, which is this whole angle here, you're going to take 180 and you're going to subtract what you just found, that reference angle, okay? So our answer actually is 146.3 degrees. Okay? So that's how we should have done that one. Now, number 4, a lot of you did it well, but a few of us had the components backwards. So just to reiterate, we want to start here and we're stopping here. So that means we are going to the right. Okay, so we're going in an X direction and we are not going in a Y direction. So that means your Y should be 0. We're not going up or down at all. And we're going to the right, so it should be positive. A few of you had like 0, 7. So that means you went up instead of right. Okay, so just be careful of that. Excuse me. Wow, that was a big yawn. Okay, so then magnitude, remember, if it's perfectly vertical or perfectly horizontal, you can just count 1, 2, 3, 4, 5, 6, 7. It's 7 units. Okay, which makes sense. If you do the Pythagorean theorem with these two numbers, you would get the square root of 49, which is 7. Okay, I'm just trying to show you kind of the fast way. And then the direction, you shouldn't have to do SOHCAHTOA. You can if you want, but just what is it if it's perfectly horizontal? Like, what if I moved it like here? Okay, because those two are equivalent. They're still the same length. Well, I guess I got to go a little bit further. They're the same length, but it's sitting right on the x-axis, and that means it's opening up none, so it's 0 degrees. Okay, it's sitting perfectly horizontal. If it were going this way, it would be 90. This way, it would be 180, and this way, it would be 270. So just FYI. Okay, and I have that work done down here as well, but I just did that for you. Okay, so that's how you should do 3 and 4. Now we're going to do a few more problems kind of similar to this, because I feel like I kind of threw the whole they're not in standard form at you. And so we're just going to do a few more practice problems, okay? All right, we did this yesterday, but I want to show you a kind of a shortcut for number 11. So do you see how number 11, V, is definitely in standard position, okay? It's sitting right at the origin, but U is not, okay? So to me, if I would have to really zoom in really hard to draw this right triangle, and I'm not feeling very confident with that. A, that's not my strength, and B, it's just kind of hard to see, and that's going to be the same for you. But I have these ordered pairs, okay? So I have 6, 5, and 2, 4. Now, I don't know about y'all, but I can count this one a little more clearly, the V one. So I can tell it goes over 4 and up 1. So the component form for V is 4 because it was going to the right, and then 1 because it's up. And they're both positive because that's clearly in quadrant 1. Now for U, vector U, another way to write or to figure this out, instead of doing like trying to draw in the right triangle, is to do subtraction. The way you're going to do this is you're going to do the terminal minus the initial points. Okay? So if I just have the points and I'm trying to find the component form, I'm just going to do terminal minus initial. So I'm going to start with the x's. So my terminal x is 6. My initial x is 2. My terminal y is 5, and my terminal y is 4. My initial, I'm sorry. Okay, so I went terminal minus initial, and then terminal minus initial. Just x and x, and then y and y. And so now I can see my component form. 6 minus 2 is 4. 5 minus 4 is 1. And you guys, this right here is the shortcut for saying, yes, they are equivalent to each other because they have the same component form. If they have the same component form, then of course the magnitude is going to be the same and the direction is going to be the same because they all revolve around using those two numbers. Okay, so basically, if you want to say they're equivalent, a shortcut is just basically finding the component form and showing that they are equivalent. Okay. All right, so numbers 13 through the rest, basically. I'm going to do a couple and then you're going to do the rest, okay? So if you notice, 13 and 14 are in standard position. So when I have this 0.13 right here, that is essentially your component form, okay? Because if you notice, we're going over 1 and up 3. The reason it's so easy is because we're starting at 0, 0. So if you were to do terminal minus initial, it'd be 1 minus 0, which is still 1, 3 minus 0, which is 3. So okay, I'm not really sure if that means this is about to go off. I hope not. So I am, sorry, I lost my train of thought. The component form when it's in standard form is basically just that initial, okay? And then it says to also find the magnitude, and so that would be the square root of 10, because 3 squared and 1 squared. Now, y'all are going to try 14. It's basically the same thing, but be careful of your signs, okay? But I think y'all can handle that one okay. Don't forget to simplify the radical also, okay? Because that will happen in 14. Now, 15, it is not in standard position, so I'm going to have to do terminal minus initial, okay? So I'm going to do terminal minus initial. Now, notice I'm doing double negative. I have to do that. and then terminal initial. Okay, so my magnitude would be 4 and 6. Now, if you feel more comfortable with just doing like this, you certainly can. I'm just giving you yet another, an alternative. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Yeah, see, just by my drawing, and I'm zoomed in, it's kind of difficult, but I can see 4, 6. Okay, so now I'm going to type in 4 squared plus 6 squared, and that gives me 52, but that can simplify into 4 and 13. And so my answer is 2 root 13. That's my magnitude. Notice it didn't ask for direction. It just asked for magnitude. And then real quick, can you tell that this would be in quadrant 1? 2 ways. A, because it's pointing in that direction, which is in quadrant 1. And also because both of these are positive. Okay? So I want you to try the same thing with 16. And then 17 and 18 are practice with those perfectly vertical and perfectly horizontal. So something should be 0, either the X or the Y. I'll make sure you figure that out. And then 19 and 22, I'm going to do 19 and then I want you to try 22. Now, again, you can just do terminal minus initial. Okay. I also want to sketch this for you so you understand that you can do that. Okay. So let me go to I've already written it down over here. All right, so 5, 1, 2, 3, 4 is here. That's my terminal, so that means that's where the arrow is going to be. And my initial is -3, -5. Okay. So now when I draw this, I need you to think, what quadrant is this really in? It starts in quadrant 3. It goes to quadrant 4, and then it lands in quadrant 1. Well, what does it really matter? It really matters where it ends or where it's pointing towards, okay? So even if it ended right here, do y'all agree it still would be pointing in quadrant 1 direction, okay? So that's a little bit of a tricky concept. Uh-oh, I did not mean to do that. Excuse me. So we should kind of envision that our component form should both be positive, because if we were to slide this like so, they would still be equivalent. They would still have the same component form, okay? But we're just going to take it as it is. So I'm going to show you both ways. I'm going to erase these quadrants so it doesn't get on your nerves. So you can draw it this way if you want, and you can do your components. I'm going to go right, and then I'm going to go up. So I'm going to go right 1, 2, 3, 4, 5, 6, 7, 8, and it's positive, and up 1, 2, 3, 4, 5, 6. Okay, now I'm going to show you the same way with the terminal minus initial. So terminal minus initial, terminal minus initial. And that gives me 8 because of the double negatives, and 6. And see, that's the same thing here and here. So if your forte or your strength is drawing, then go for this method. If you just want to do the straight up algebra, go for this method. That's kind of what I choose. And then the magnitude would be 64 plus 36, which is 100. And that is a perfect square, so our distance is 10. Okay, or the magnitude. So what I want you to do is I would like for you to do 14, 16, 17, 18, 22. So that's 1, 2, 3, 4, 5. Notice the directions say find the component form. And y'all, some of y'all are putting these kind of parentheses, but I do want you to put those. Okay, you can do that. It's if you hold shift and do the period and then the comma. Those will get those for you. So try to do those if you will. And then you're going to either put it in square root form or simplified square root form for magnitude. Okay, don't forget to simplify the radicals if you need to. I hope you have a great weekend. We will continue with vectors on Monday.